Ever read a sentence that sounds completely normal, like something you'd say to a friend or write in a quick work email, but then an English grammar test tells you it is just wildly, fundamentally incorrect?
Oh, yeah. It happens all the time.
Yeah.
I mean, our brains are incredibly good at extracting meaning from messy, imperfect language.
Right.
We prioritize speed and, conversational flow over structural perfection.
Yeah.
But when you step into the world of advanced language testing, that casual brain is actually your biggest liability.
Wow. Yeah. And that is exactly what we are dismantling today. Welcome to today's deep dive. If you're joining us, you are in for a really fascinating linguistic workout.
We certainly are.
We are looking at a very specific source today. It's section 1 of the English language portion from the IBPS CRP PO MT 2026 model paper 02. And whether you are actively preparing for this exam or you just want to understand the hidden architecture of English, this is for you. We're going to cover all 30 questions sequentially, starting from big picture reading comprehension down to the invisible math of sentence structure.
Exactly. And my goal today is to give you, the listener, the analytical framework to see right through these testing tricks. We aren't just going to read an answer key. We want to neutralize any theoretical ambiguities. We are going to look at why English demands these specific rules and how mastering them can actually change the way you process information.
I love that. So let's jump right into the deep end with macro comprehension. Questions 1 through 8 are based on a reading passage about India's booming gig economy.
Right. A very timely topic.
Very. And the passage outlines how easy it is to enter this workforce. You basically just need a smartphone and a two-wheeler. But it also highlights the dark side, right? These workers are independent contractors, their earnings fluctuate, and a welfare fund from 2020 has been painfully slow to reach them.
Which is a beautifully constructed trap by the test writers.
Wait, a trap? I mean, the passage seems pretty straightforward to me.
The topic is straightforward, sure. But its real-world relevance is the trap. When you read about the gig economy, your brain wants to pull in everything you already know about, like food delivery apps. The test evaluates whether you can rely strictly on explicitly stated facts.
Ah, I see. Okay, let's test that with question 1. The core concept here is explicit fact retrieval. It asks, what is often enough for a young worker to begin gig work? My brain immediately thinks, well, you probably need a bank account, maybe a clean driving record.
And those sound highly logical. But the analytical progression here demands strict textual adherence. The correct choice is D. A smartphone and a two-wheeler.
Because it's right there in the text.
Exactly. The passage explicitly states those are often the only requirements. It neutralizes distractors like bank loans or degrees. If it's not in the ink on the page, it simply does not exist for the sake of the test.
That is ruthless, but it makes total sense. So moving to question 2, this one evaluates data discrimination. The passage throws multiple numbers at you, and the question asked for the estimated number of gig workers in 2020-21.
Right. And under time pressure, you might just grab the biggest number. But the correct choice is B, about 77 lakh.
Not the 2.35 crore?
No, because you have to distinguish the historical estimate, which is 77 lakh for 2020-21, from the future projection of 2.35 crore for 2029-30. You're mapping a timeline, not just reading numbers.
Got it. Okay, question 3 tests cause and effect inference. It asks why these workers lack protections like paid leave.
The correct choice here is D, independent contractors. The passage directly links their lack of protections to this specific legal employment classification, contrasting them with permanent employees.
Right. It's structural causality. Then for question 4, we have detail extraction. It asks what the Code on Social Security 2020 proposed.
And again, strict adherence to the text. The correct choice is B, welfare fund. The 2020 Code specifically proposed a welfare fund, even if its implementation is slow. You can't invent other policies.
Makes sense. Now, question 5 is a true-false evaluation. You have to identify the true statement among a list of logical-sounding claims about gig workers.
This is where you rely on the facts presented. The correct choice is C. Earnings can fluctuate with demand and fuel prices.
Because the text specifically complains about that, right?
Exactly. All the other options, like guaranteed wages, are direct factual reversals of the passage's claims. So C is definitively correct.
Okay, that brings us to the vocabulary questions tied to this passage. Question 6 looks for a contextual synonym for the word fluctuate. Why not just, give a standalone vocabulary quiz?
Because words don't have fixed meanings outside of context. They have semantic fields. Fluctuate regarding earnings implies an irregular rising and falling rhythm. So the correct choice is B, vary.
Not words like settle.
No, settle or freeze are static distractors. Vary is the only option that captures that irregularity.
Got it. Question 7 is also a contextual synonym, this time for caution, as in experts caution about the slow implementation.
In this semantic environment, the correct choice is E, warn. To caution about something slow and problematic is to issue a warning.
Okay, and finishing up this section, question 8 asks for a contextual antonym, the opposite of flexible.
Right. A casual speaker might say a strict schedule is the opposite of a flexible one, but logically, the mechanical opposite of flexible, the ability to adjust, is rigid. So the correct choice is A, rigid.
It's like turning language into a precise mathematical formula.
It really is.
Which brings us perfectly to Section 2, Contextual Cohesion, questions 9 through 13. We're moving from a full passage to a closed test filling in the blanks of a paragraph about road accidents in India.
This is where understanding context naturally leads to identifying the exact right word.
So let me read the first bit for question 9. Road accidents blank thousands of lives in India every year. My brain goes, well, accidents cause deaths, they take lives, but the concept here is lexical collocation.
Yes. And the correct choice is C, claim. English is full of predictable habitual pairings. Accidents claim lives. It is standard formal English phrasing.
So words like save or rescue invert the meaning, obviously.
Exactly. And even take lacks the formal collocation strength of claim in this specific syntactic slot.
Oh, wow. Okay, question 10 follows right after, and a large share of these deaths is entirely blank. We know these are caused by human errors like overspeeding. The concept is contextual semantics.
Right. So if a tragedy is caused by changeable human behavior, it is avoidable. The correct choice is D, preventable. It's a logical deduction.
Makes sense. Now, question 11 always trips people up, phrasal verbs. Experts note that overspeeding, drunk driving, and riding without helmets blank for most fatalities. Why can't I say they blame for most fatalities?
Because of the preposition for sitting right there, blame doesn't pair with for in this direction. The correct choice is A, account.
Account for.
Yes, account for means to be the cause of. No other option forms a valid phrasal verb in this semantic context.
It's like a puzzle piece. Okay, question 12 is about legal vocabulary. The government has blank stricter penalties.
The correct choice is C, introduced. New, stricter penalties under an amended act are introduced. Words like withdrawn or repealed would mean removing penalties, which makes no sense here.
Right. And for question 13, the concept is contrastive logic. The text says we need to treat rules as a matter of personal safety rather than something else.
That phrase, rather than, is a huge signpost. It means the blank must contrast with internal personal safety.
So doing it because you're forced to.
Exactly, which definitively points to the correct choice, decompulsion.
Amazing. Okay, moving to section 3, structural logic. Questions 14 through 17. We have to organize 5 completely standard sentences, A through E, into a logical paragraph.
Parajumbles. These can be intimidating.
Yeah, honestly, when I look at a wall of scrambled text, my eyes just glaze over. The sentences talk about internet access, learning apps, exam prep, teacher warnings, and a blended model. How do we even begin finding the sequence?
You begin by finding the foundational pillar, the topic sentence. You need the sentence that stands completely on its own without relying on pronouns or transitions from other sentences.
Okay, looking at the options, sentence D says, internet access has spread rapidly across India's small towns. That doesn't need any prior information.
Correct. So for question 14, which asks for the topic sentence, the correct choice is D. It establishes the baseline theme.
Okay, so D is first. Then what?
You follow the logical breadcrumbs. What happens because internet access spread?
Sentence A says, writing on this growth, learning apps now reach small towns.
Yes, A builds on D. Now, who uses those apps?
Students. Sentence C says, many students use them to prepare for exams at low cost.
Perfect. So for question 15, which asks for the sequential linking of the third sentence, the correct choice is C.
Got it. And question 17 actually asks which sentence immediately succeeds A.
Which we just solved. The correct choice is C. It explicitly details what happens once the apps reach the learners mentioned in A.
So our sequence is DAC, but we have B and E left.
Right. Now we introduce tension. What is the counter-argument to these apps?
Sentence B. However, teachers warn that screens cannot replace classrooms, and that leaves E to resolve it. A blended model combining both is emerging as the way forward.
Spot on. So for question 16, asking for the concluding statement, the correct choice is E. It serves as the ultimate resolution. The full logical trajectory is DACBE.
It is so satisfying when it clicks like that. But now we are shifting gears to section 4, micromechanics. Questions 18 through 22, error spotting.
This is where we have to completely turn off the casual speaking brain.
Yeah, I'll read a sentence that sounds totally fine, and you tell me why it's technically a disaster. Question 18 evaluates subject-verb agreement with collective nouns. The committee have submitted its report to the chairman. I hear people say this all the time.
It feels right to the casual ear, but we must isolate the subject. The committee is acting as a single, unified entity here.
How do we know that for sure?
Look at the pronoun later in the sentence. Its report. Its is singular. Therefore, the verb must align. The correct choice is B. The error is in part B. Have submitted must be corrected to the singular has submitted.
Wow, the clue is hiding in plain sight. Okay, question 19. Subject-verb agreement with distributive pronouns. Neither of the two answers given by the student were correct in the examination. My brain hears two answers, so were sounds perfect.
And that is the cognitive trap. Your brain grabs the closest noun. But of the two answers is just a prepositional phrase. The true subject is the distributive pronoun neither.
And neither is always singular.
Inherently singular. So despite the plural noun floating nearby, the correct choice is C. Were correct is an error. It must be was correct.
That is super sneaky. Question 20 evaluates adverbial inversion. Hardly had he reached the station when the train started moving slowly. Is there an error there? It sounds a bit, I don't know, old-fashioned.
It sounds formal, but grammatically the correct choice is E. No error. When you start with a negative adverb for dramatic emphasis like hardly, standard syntax must be inverted. You don't say hardly he had reached. You must say hardly had he reached. It's flawlessly executed here.
Good to know. Okay, question 21. Noun number after partitives. One of my friend has been selected for the probationary officer post. I definitely make this mistake in conversation.
Let's break down the logic. The phrase one of implies selecting a single item from a larger available group.
Right, you can't select one out of a group of one.
Exactly. So the noun that follows one of must universally be plural. The correct choice is A. One of my friend is an error. It must be one of my friends. The singular verb has later on is correct because the subject is one, but the pool must be plural.
That makes total sense. Question 22 evaluates future time clauses. The bank will refund the excess charges when the customer will submit the form.
This tests the rule against double future constructions. The main clause is future tense. The bank will refund. But a subordinate clause introduced by when cannot also be in the future tense, even if the action happens in the future.
So it needs to be present tense.
Yes. Standard English requires the simple present here. The correct choice is D. Will submit the form must be corrected to submits the form.
Right. Establish the future once and let the time clause support it.
Precisely.
Well, identifying the error is one thing, but fixing it is another. Section 5, questions 23 through 25 is syntactical refinement, phrase replacement. Why does English force us to use such specific word pairings?
These pairings, or correlative conjunctions, are cognitive signposts. When you see the first word, your brain anticipates the second. It allows for faster comprehension. Breaking the pairing disrupts the cognitive flow.
Let's look at a signpost in question 23, correlative conjunctions and inversion. The phrase to replace is, scarcely the meeting had begun than the lights went out.
We have two mandates violated here. First, scarcely requires adverbial inversion, so it must be had the meeting begun. Second is the signpost. Scarcely is inextricably paired with when, not than.
Ah, so then is wrong.
Completely invalid, yes.
Yeah.
Than only pairs with no sooner. So the correct choice is E, had the meeting begun when.
Got it. Question 24 evaluates subject-verb agreement with determiners. The phrase is, the number of applicants have increased sharply this year. To me, the number of and a number of mean the exact same thing.
Colloquially, maybe. Grammatically, they are opposites. A number of is an undefined plural, meaning several, so it takes a plural verb. But the number of designates a single, specific, calculable quantity.
Oh, so it demands a singular verb.
Exactly. The correct choice is B, has increased. It's a deliberate contrast.
Okay, question 25. Verb complementation, specifically infinitives versus gerunds. He denied to accept the award at the ceremony. I understand what it means, but it's clunky.
You understand the intent, but the grammar is broken. The verb refuse is followed by a to infinitive reflecting a deliberate choice not to perform an action.
So, refuse to accept. What about deny?
Deny requires a noun or a gerund, usually reflecting the rejection of a stated fact. You deny an accusation. You cannot deny to do something. So the correct choice is C, refuse to accept.
We are in the home stretch. Section 6, final Polish. Questions 26 through 30 focus on fillers and word swaps. I kind of think of this as solving a math equation using words.
That is an excellent analogy.
Like, if the sentence has a positive vibe, you need positive vocabulary. Let's look at question 26. Semantic alignment. The government hopes the new policy will blank investment and blank thousands of jobs.
The word hopes is our positive operator. A government hoping for an economic outcome mathematically dictates positive, generative actions. The correct choice is E, attract and create.
Because words like shrink would invalidate the intent.
Exactly.
Question 27 evaluates concessive contrast. Despite blank evidence, the officer remained blank about the suspect's involvement.
The operator here is despite, which demands a contrast. The two halves of the sentence must oppose each other. If the evidence is strong, overwhelming, the officer's reaction must be the opposite of convinced.
Right, so the correct choice is B, overwhelming and skeptical.
Yes, it satisfies the equation perfectly.
Awesome. Question 28 looks for a logical action-result pair. The committee blanks several changes to make the process more blank.
What is the fundamental action of a committee? They recommend or suggest things. And what is the goal of changing a process? Usually to make it clearer. So the correct choice is A, suggested and transparent.
Perfect fit. Now, the last two are word swaps, where we check if bolded words need to trade places. Question 29 evaluates syntactic and semantic validity. Rapid urbanization has put enormous pressure on civic amenities in most cities.
What does your analytical brain tell you here?
Honestly, it tells me to leave it alone. Rapid urbanization causes enormous pressure, which falls on civic amenities. Everything aligns.
And you would be right. The correct choice is E, no interchange required. Sometimes the test evaluates your confidence to recognize perfect idiomatic integrity.
But question 30 definitely needs a swap. Lexical collocation swaps, listen to this. The judge delivered the culprit and sentenced a stern warning to the court before adjourning the hearing. I'm picturing a judge physically carrying a criminal into the room.
It's a wonderfully absurd image. And it shows why collocations matter in legal terminology. A judge does not deliver a person, and you cannot sentence a warning.
So we swap them.
Yes, to restore the rigid idiomatic framework. A judge sentences a culprit assigning punishment and delivers a warning speaking it. The correct choice is A, swapping A, and B, delivered and sentenced.
And just like that, we did it. We methodically unpacked the conceptual mechanics behind all 30 questions in this section.
We really did. And, if you've been following along with us, you just completed a massive cognitive workout.
Absolutely.
And it pays incredible dividends. Because whether you work in finance, engineering, or the arts, mastering these rules, really understanding the why behind the grammar, builds a permanent framework for authoritative communication.
It really does. Which leaves us with this final provocative thought for you to mull over today. Think about how often we rely on our casual conversational brain when we send quick texts or emails at work. If you started deliberately applying today's strict rules like perfect subject-verb agreement with collective nouns or hyper-precise vocabulary collocations to your everyday writing, how might that subtly shift the way people perceive your competence and your ideas?
It's a great question. Because ultimately, absolute clarity of language leads to absolute clarity of thought.
Beautifully said. Thank you for joining us on this deep dive. And as always, keep pushing yourself to learn. You know that feeling when you first look at a massive wall of numbers on an exam paper?
Oh, absolutely.
Yeah, there's this sudden, just massive spike of adrenaline. It feels like you are standing at the base of a sheer cliff looking up, and your brain just whispers,
Yep.
Nope, absolutely not.
Right, and I always tell students that it's a completely natural reaction. We are biologically conditioned to see a dense page of data and equations and percentages as this insurmountable threat.
Like a predator in the wild.
Exactly. But it is an illusion. The test makers, they actually rely on that initial panic to weed people out before the math even begins.
And that illusion is exactly what we are going to dismantle today. Welcome to our deep dive. Today, we have a singular, highly specific mission. We are taking on the ultimate final boss of the IBPS Bank PO exam.
The Quantitative Aptitude section.
Yes, specifically, we are looking at Section 2 of the IBPS CRP PO 2026 Preliminary Examination Model Paper ZU2. For the audio file identification, this is covering questions 31 through 65, which corresponds exactly to slides 37 to 74 in the source material.
And we are not skipping a single thing.
Not a single slide. We are going to walk through this sequentially. And if you are listening right now, I want you to take a deep breath and just drop your shoulders. We are going to break down this entire model paper from the first data puzzle to the final word problem.
Because this isn't actually a test of raw, unapproachable genius. It is testing your strategy. Quantitative aptitude is simply a series of small, highly manageable puzzles.
Right.
You don't have to scale the whole cliff at once. You just have to find the next handhold. So we're going to walk alongside you, explaining not just how to find the answers, but, well, the underlying logic the exam designers are using to test you.
We are your guides. We will look at extracting data from text, interpreting visual charts, weighing abstract equations, spotting hidden patterns, and finally untangling those real-world scenarios.
So let's jump right into the very first hurdle they throw at you on slide 37, the caselet.
Yes, the caselet.
Yeah.
It is essentially a wall of text. They describe a scenario, and they bury the numbers inside paragraphs. It's like a reading comprehension test, and a math test had a very stressful baby.
That is a great way to put it. For this one, they give us a college of 1,200 students. We were told the ratio of boys to girls is 7-5. We also learned that 60% of the boys and 45% of the girls play cricket, while the rest do not.
Okay.
And from this one paragraph, they're going to ask you 5 different questions from 31 to 35.
I always compare this to organizing a massive banquet. Before you even think about serving the food, which is, answering the actual questions, you need to know exactly how many people are sitting at each table. How many boys? How many girls? Players versus non-players?
Exactly.
But here's where I get stuck under strict time pressure. Should you calculate all these base numbers first, or just figure them out question by question as they come up?
Always calculate the base numbers first. I really cannot stress this enough. When you are under the ticking clock of an exam, doing the foundational math up front drastically reduces your cognitive load.
So prep the tables first.
Right. If you try to calculate percentages while also trying to answer a complex hypothetical question, you will make a simple arithmetic error. Let's set the tables. We have 1,200 students total, split into a 7-to-5 ratio of boys to girls.
Okay, so a 7-to-5 ratio means there are 12 equal parts in total. If we divide the 1,200 students by 12, each part is exactly 100 students. That makes it super clean. 7 parts boys means 700 boys, and 5 parts girls means 500 girls.
Spot on. And then we apply the cricket percentages. We know 60% of those 700 boys play. Well, 6 times 7 is 42, giving us 420 boys playing cricket.
Got it.
And for the girls, it is 45% of 500. A quick mental trick here, 50% will be half, so 250.
Right.
Subtract 5%, which is a tenth of that, so 25.
Okay.
That leaves 225 girls playing cricket.
Okay, now the tables are fully set. We know 420 boys play, which means 280 don't. And 225 girls play, meaning 275 don't. And this is where that upfront work pays off, because the follow-up questions suddenly feel, honestly, almost effortless.
They really do.
Yeah.
Let's look at question 31. It asks how many boys do not play cricket.
You aren't doing any complex algebra there. You are just looking at your table. 700 boys total, minus the 420 who play, leaves 280 who don't. Boom, done.
Exactly. Moving to question 32, they ask for the total number of students playing cricket. You just combine the player columns you already mapped out. 420 boys plus 225 girls equals 645 total players.
It's like they're rewarding you for being organized.
They absolutely are. Question 33 asks for the ratio of girls who... and then share a factor of 15, which simplifies smoothly down to 15 to 28.
Then question 34 asks for the percentage of total students who play cricket.
And again, you already know 645 students play out of the 1,200 total.
Right, so 645 divided by 1,200, you divide by 12, and it works out to exactly 53.75%. And then for question 35, they always throw in a what-if scenario to see if you can manipulate your own data. Like, what if 20% of the girls who do not play cricket suddenly decide to join the team?
Because you mapped it out initially, you know exactly how many girls don't play. It's 275. 20% is just 1/5.
Okay, so a fifth of 275 is 55.
Yes. Add those 55 newly athletic girls to the original 225 who are already playing, and you have 280 girls playing cricket. You have answered 5 questions in a matter of seconds because you controlled the data.
Rather than letting the data control you. I love that. Control the data. Which brings us perfectly to the next challenge, covering questions 36 to 40. We are moving from a wall of text to visual data, a literal pie chart mapping out a company's departments.
Visual data requires a slight shift in strategy. The chart shows 5,400 total employees distributed across 5 slices. IT has 30%, sales 25%, operations 20%, finance 15%, and HR 10%.
So question 36 asks a direct question. How many people work in the IT department? That is straightforward. IT is 30% of 5,400, which gives us 1,620 employees.
Very straightforward. But question 37 is where they lay a trap. They ask for the respective ratio of employees in sales to those in finance.
Right, and the instinct is to calculate the raw headcounts for both departments first, isn't it?
That is the exact trap they want you to fall into. They want you to waste 2 minutes finding 25% of 5,400 and then 15% of 5,400 just to compare them. But if you were listening on a walk or a drive right now, just picture the pie chart in your mind.
Okay, got it.
The slices are all cut from the exact same pie. You don't need to count the individual people to compare the sizes of the slices.
Oh, so you just use the raw percentages. Sales is 25%, finance is 15%. The ratio 25 to 15 instantly reduces to 5 to 3. That completely eliminates the need for large number multiplication. That's a huge time saver.
Precisely. And you could apply this shortcut to addition and subtraction too for question 38. It asks how much the number of employees in IT and operations combined exceeds the number in HR and finance combined.
Okay, let's test that. Stay in the percentage realm. IT plus operations is 30% plus 20%, so a 50% slice of the pie. HR plus finance is 10% plus 15%, so 25% slice. The difference between them is just 50 minus 25, which is 25%.
Exactly.
So instead of calculating 4 separate headcounts, I just need to find 25%, 1/4 of the total 5,400 employees. Half is 2,700, half of that is 1,350. Boom.
Notice how using these percentage shortcuts strips away the mental fatigue. You need to conserve your mental energy. Question 39 asks for the average number of employees in sales and operations.
Okay, sales is 25%, ops is 20%. That is 45% total. Since it is an average of 2 departments, divide 45 by 2, that is 22.5%. So we just need 22.5% of 5,400.
Which is 12,215. Even if they introduce a subcategory, like in question 40, they say 40% of the finance employees are women and ask how many are men.
Correct. So 60% of 810, 6 times 81 is 810. It keeps the math grounded and linear.
That makes total sense. Now, let's transition away from counting people and dive into abstract logic for questions 41 to 45. The inequalities section. This is where they give you a quadratic equation for x and an equation for y and ask you to compare them.
This is a section that intimidates a lot of people. Oh, for sure. I always think of this like placing weights on a massive scale. We don't just care about the exact numerical answers. We care about which side of the scale is consistently heavier.
A fantastic analogy. With these quadratic equations, you are finding the roots, the possible values for x and y. You're basically finding the absolute heaviest and lightest each side could possibly be, and then seeing how the scale tips.
Okay, let's look at question 41. The x equation is x squared minus 13x plus 40 equals 0. The roots there are 5 and 8. The y equation is y squared minus 7y plus 12 equals 0. The roots are 3 and 4.
So compare them on your scale.
Well, no matter which version of x or y we pick, the lowest x, which is 5, is still heavier than the highest y, which is 4. The scale permanently tips toward x, so x is strictly greater than y.
Exactly. Question 42 gives us x squared plus 5x plus 6 equals 0. Roots are -2 and -3. And y squared minus y minus 2 equals 0, giving roots of 2 and -1.
Here, the highest x is -2, the lowest y is -1. So y is always heavier, x is less than y. But the test makers rarely keep it that simple, right?
Right. The real challenge comes when the boundaries overlap. Look at question 43. X squared minus 6t equals 0, so x is either 4 or -4. But the y equation, y squared minus 9y plus 20 equals 0, gives roots of 4 and 5.
Oh, this is where we have to pay very close attention. The x scale can weigh 4, and the y scale can also weigh 4. They overlap right there. They can be perfectly balanced.
Correct. But look at the other possibilities. If they aren't both 4, x is sitting way down at -4 while y is up at 5.
So x is either significantly lighter than y or exactly equal to it. It can never be heavier. That makes the answer x is less than or equal to y.
Spot on. Question 44 has x roots of 2.5 and 2, and y just has a root of 2. By the same logic, x is greater than or equal to y. But question 45 is the tricky one.
Let's see. X squared minus x minus 6 equals 0. Roots are 3 and -2. And y squared minus y plus 6 equals 0, giving roots of 2 and 3.
Okay, put that on your scale.
If x is 3 and y is 2, the scale tips toward x. But if x is -2 and y is 3, the scale violently tips toward y. They cross over each other.
Exactly. When the values leapfrog each other like that, the mathematical answer is no relation can be established. It is a perfectly valid option on the multiple choice list, and it is one you should not second guess. If the scale tips in both directions, you simply cannot establish a consistent relationship.
I love that clarity. Let's keep moving into pattern recognition, starting at slide 52. The wrong number series for questions 46 to 50. This is where they give you a sequence of numbers that follow a hidden logical rule, but one number breaks the matrix code, and you have to spot the imposter.
And I know a lot of people just freeze when they see these.
Yeah, completely.
They do, because our brains struggle to process rapid, unexplained changes in scale. But you can train your intuition by looking at the shape of the series. Don't look at the specific numbers first. Look at how fast they're growing or shrinking.
Let's break that down into practical advice with question 48. You see a series dropping rapidly, starting at 720, then plummeting to 120, then to 24, 8, 2, 1. What should your instinct be?
Your brain should instantly flash a neon sign saying division. Don't even bother checking addition or subtraction. You were just hunting for denominators. 720 divided by 6 is 120. 120 divided by 5 is 24.
Oh, so you can see the pattern of dividing by decreasing integers, so the next step should be 24 divided by 4, which is 6.
Exactly. But the series lists an 8 instead of a 6, so 8 is your imposter.
Got it. What about question 47? The numbers are inching up, then suddenly leaping. 2, 6, 15, 31, 56, 93.
That shape usually points to perfect squares.
Okay.
Look at the gaps between the numbers. The gap between 2 and 6 is 4. Between 6 and 15 is 9. Between 15 and 31 is 16.
Ah, those gaps are 2 squared, 3 squared, 4 squared.
Yes. The next gap is 25. 31 plus 25 is 56. So the gap after that must be 36. But 56 plus 36 is 92. The series says 93, so 93 is the wrong number.
And what if it is a smooth escalating curve where the numbers roughly double each time? Like question 46, 5, 11, 23, 47, 96, 191.
That points to a combined operation. Multiplication plus a constant. 5 times 2 is 10 plus 1 is 11. 11 times 2 is 22 plus 1 is 23. You just test that rule until it fails. 47 times 2 is 94 plus 1 is 95, but they wrote 96, so 96 is the imposter.
The same logic applies to question 49, which is a bit more complex. 3, 5, 13, 43, 176, 891.
Right. Here the multiplier increases. 3 times 1 plus 2 is 5. 5 times 2 plus 3 is 13. 13 times 3 plus 4 is 43. 43 times 4 plus 5 should be 177, but the series has 176.
And a pro tip for question 50. The series is 8, 12, 26, 60, 180, 630. If you see it growing in a way that feels like it involves halves, start testing decimal multiplication.
Yes, exactly. 8 times 1.5 is 12. 12 times 2 should be 24, but they have 26. So 26 is the imposter, because if it were 24, the next step, 24 times 2.5 perfectly equals 60. Once you learn to recognize the shape of the math, the imposter stands out.
Which brings us perfectly to the speed math section, questions 51 to 55, simplification and approximation. Once you know the rules, it's just about flexing your calculation muscles without panicking.
It really is a test of nerves as much as math.
Like when they throw terrifying decimals at you in question 54, something like 63.98% of 550.01 plus 24.02% of 249.99. If you are staring at that on a screen, your heart rate naturally spikes.
It does, but you have to remember the context. This is an approximation section. The multiple choice answers are spaced out. Don't fear the decimals, just round them cleanly. Treat it as 64% of 550 plus 24% of 250.
Right, which completely changes the emotional reaction to the problem.
Exactly. Gives you 352. For 24% of 250, that is the same as 25% of 240, which is just a quarter of 240, so 60. 352 plus 60 is 412.
That's a great trick flipping the percentage around. And this is also where memorizing your foundational numbers pays immense dividends, like in question 52, square root of 2025 times 12 minus 15 squared.
You should just know the square root of 2025 is 45, and 15 squared is 225. So it's 45 times 12, which is 540, minus 225, giving you 315.
Same with question 53, 17 squared plus 19 squared, all divided by 26. You shouldn't be doing long multiplication in the margins. You just recall it's 289 plus 361, which is 650. Divide by 26 to get 25.
Memorizing squares up to 30 buys you precious minutes for the final, most difficult section of the exam.
And we just knocked out question 51 and 55 with basic fraction and percentage math. So that brings us to the final stretch, the marathon.
The arithmetic word problems, questions 56 through 65.
We are taking all our calculation speed and all our logical reasoning and applying them to 10 different real-world scenarios. We have to translate English into algebra. Let's look at the classic boat and stream problem in question 56. A boat travels 12 kilometers per hour in still water, and the stream flows at 3 kilometers per hour. How long does it take to travel 45 kilometers downstream?
The translation here is all about combined forces.
I always picture walking on an airport moving walkway. If I am walking forward at a certain speed and the floor itself is pushing me forward, I don't just use my walking speed, I add them together.
That is the perfect way to visualize it. Because the stream is pushing the boat, You aren't traveling at 12 anymore. The water adds its 3 to your speed, so you're cruising at 15. To go 45 kilometers at a speed of 15 takes exactly 3 hours.
Nice and clean. Now, question 57, a compound interest problem. 8,000 rupees invested at 10% per annum for 2 years. What's the compound interest?
Think of it in steps. Year 1, 10% of 8,000 is 800. Year 2, you get another 800, plus 10% on the first 800, which is 80. So 800 plus 880 is 1,680.
Easy. How about question 58, a pipes and cisterns problem? Pipe A can fill a tank in 10 hours, and Pipe B can fill it in 15 hours. How long does it take if they work together? The trap here is that people try to average the time.
Right, they think, well, 10 and 15, maybe it takes 12.5 hours. But that makes no physical sense. If you have 2 hoses filling a pool, it's going to be faster than just using one.
Exactly.
You cannot add their hours, you have to add their rates of work. Pipe A completes 1/10 of the job per hour. Pipe B completes 1/15. You have to find a common denominator, in this case 30, and add those fractions. 3 over 30 plus 2 over 30 is 5 over 30, which reduces to 1/6, meaning they complete 1/6 of the tank per hour together.
So the whole job takes 6 hours. Let's tackle question 59. Mixtures. 40 liters of a mixture has milk and water in a 7:3 ratio. If 8 liters of water are added, what's the new ratio?
Break down the original 40 liters first. 7 parts milk, 3 parts water means 10 parts total. So each part is 4 liters. That means 28 liters of milk and 12 liters of water.
Then we just add the 8 liters of water, so water goes from 12 to 20, the milk stays at 28. The new ratio is 28 to 20, which simplifies to 7 to 5.
Perfect. Question 60 is probability. An urn contains 5 red, 4 blue, and 3 green balls. If you draw 2 balls at random, what's the probability both are red?
Okay, there are 12 balls total. We want 2 red ones out of the 5, so use combinations. 5 choose 2 for the favorable outcomes, which is 10, and 12 choose 2 for the total possible outcomes, which is 66. So 10 over 66, simplifying to 5 over 33.
You are flying through these.
Well, question 61 is profit and loss, which I love. A shopkeeper marks an article 25% above cost, but then allows a 12% discount to the customer. What is his actual profit percentage?
The strategy here is never use algebra if you don't have to. Pick a clean, friendly baseline number.
Right. Let's assume the item costs the shopkeeper exactly $100. He marks it up 25%, so the price tag says $125. Then he offers a 12% discount on that new price. Well, 12% of $125 is $15. So he sells it for $125 minus 15, which is $110. He bought it for $100, sold it for $110. That is a crisp, undeniable 10% profit.
That instinct to use 100 as your baseline is crucial. Let's look at question 62, ages. The present ages of A and B are in the ratio of 5 to 7. After 6 years, the sum of their ages will be 60. Find B's present age.
You represent their current ages as 5x and 7x, and the key is remembering that time affects everyone equally. In 6 years, A doesn't just get older while B stays the same. A becomes 5x plus 6, and B becomes 7x plus 6.
Right, and when you add those new ages together, it equals 60. Combine the x's to get 12x. Combine the 6's to get 12. So 12x plus 12 equals 60. 12x equals 48. X equals 4.
And since B's current age is 7x, 7 times 4 is 28. B is 28 years old. We have 3 left. Question 63 is averages. Oh, wait, no, he averages 40 runs in 9 innings. How many runs must he score in his 10th innings to raise his average to 42?
Total runs is average times innings. So for 9 innings at 40, his total runs is 360. He wants his new average to be 42 across 10 innings, so his new total needs to be 420. The difference is 420 minus 360, which is 60 runs.
Question 64 is straight formula application for mensuration. Find the curved surface area of a cylinder with radius 7 and height 10.
The formula is 2 times pi times radius times height. So 2 times 22 over 7 times 7 times 10. The 7s cancel out beautifully, leaving 2 times 22 times 10, which is 440 square units.
And that sets us up perfectly for the final question of the section. Question 65 is a classic percentage trap that relies entirely on shifting the baseline. The question states, A's income is 25% more than B's. By what percent is B's income less than A's?
This is a fantastic trap.
It really is, because human intuition immediately shouts 25%. If A makes 25% more than B, then logically B must make 25% less than A, right? It feels perfectly symmetrical. But that's the trap.
Exactly. Percentages are not symmetrical because the baseline, the number you are comparing everything to, has changed. Let's use your trick and set a clean number. Let's say B earns 100. A earns 25% more. So A earns 125.
Okay, so the actual dollar gap between them is indeed 25.
Yes. But look closely at the phrasing of the question. By what percent is B less than A? The phrase then A is the secret instruction manual. It tells you that A's income is our new baseline. We aren't comparing the $25 gap to B's 100 anymore. We're comparing it to A's 125.
Oh, So we ask, 25 is what percentage of 125? And 25 over 125 simplifies to 1/5, which is exactly 20%. B earns 20% less than A. That is such a subtle, brilliant trap.
It is. It tests whether you are reading carefully or just reacting on autopilot.
Wow. And just like that, we have walked through the logic of an entire bank PO quantitative section, from organizing a banquet of cricket players in a caselet, to visualizing pie charts, to weighing quadratic equations on a scale, to navigating the moving walkways of word problems.
If you followed along with this, you should feel incredibly proud. By engaging with these strategies, you aren't just memorizing math formulas. You are building mental resilience. Yeah. You are learning to recognize traps, conserve your cognitive energy, and break down overwhelming walls of data into manageable pieces.
So what does this all mean for you outside the exam hall? Consider this. When you train your brain to quickly identify the imposter in a number series, or to strip away the noise to find the true baseline of a percentage problem, you are fundamentally rewiring your brain.
You really are.
You are training yourself to look at the chaotic variables of everyday life, whether it's a confusing mortgage rate, a complex project at work, or just navigating a crowded schedule with calm, unshakable logic.
That is a very powerful reason. The math is just the training ground.
I want to leave you with a thought to mull over today. Think back to that imaginary sheer cliff at the start of this deep dive, that feeling of panic when facing a wall of numbers. Now look at how you just dismantled it by searching for the underlying patterns. What other massive, seemingly insurmountable challenges in your life are you currently viewing as a single, terrifying cliff that could actually be conquered by simply finding the next logical handhold?
Keep breaking the puzzles down. You've got this.
Yeah.
Imagine someone looks you dead in the eye and says, "All roses are flowers. No flower is a leaf. Therefore, some leaves are roses."
Oh, yeah. Your brain just instantly knows something is deeply, deeply wrong there.
Exactly. But, I mean, if you had to actually prove exactly why it's wrong, suddenly you have to run this massive mental gymnastics routine just to explain basic reality.
It is a really fascinating cognitive friction, honestly, because, we process logic intuitively all day long.
Right.
But the moment you are asked to formally map it out, well, the brain tends to just freeze. It is that classic fight, flight, or freeze response.
Totally.
And for most people, staring down a standardized logic exam triggers a massive freeze.
Well, welcome to today's deep dive. Because if you are listening to this right now, you might be gearing up for a major cognitive hurdle of your own.
Well, might be, yeah.
Our mission today is to tackle Section 3, the Reasoning Abilities section of the IBPS CRP PO 2026 Preliminary Examination Model, Paper 2.
That is quite a mouthful.
It really is.
Yeah.
But we are going to walk through the exact sequence of all 35 puzzles in this section, from question 66 straight through to 100.
Step by step.
Exactly. So if you are feeling a spike in blood pressure just at the thought of an exam paper, take a breath. We aren't just going to read you a dry answer key.
Absolutely not. I mean, this section isn't actually about banking or management at its core.
What is it about then?
It is a mental gymnasium. It is designed to train your brain to recognize patterns, filter out noise, and most importantly, stay calm under pressure.
I love that.
So we are going to break down not just what the answers are, but why your brain wants to fall for the traps along the way.
Okay, so grab a mental notepad. Let's unpack the first sequence of logic, starting with question 66, which is all about linear arrangements, like stacking items and scheduling days.
Right, the classic box puzzle.
Yeah, so we have 7 boxes labeled A through G, stacked vertically. And when I look at a problem like this, I immediately think of trying to organize a really messy closet.
It's a good way to look at it.
You don't just shove things in randomly, right? You have to find your foundational pieces first.
That is a perfect analogy. In cognitive psychology, we call those foundational pieces anchor clues.
Anchor clues. Okay.
Yeah, because our working memory can only really hold about 4 to 7 pieces of information at once. If you try to memorize the whole stack, you will just fail.
Oh,
So the test gives you an anchor. It states that only 2 boxes are kept above box F.
Oh, so in a stack of 7, that makes box F completely immovable.
Precisely. It is locked right into the 5th position from the bottom.
And from there, the rest of the puzzle just cascades, right?
Mm-hmm.
You're no longer juggling 7 unknown variables.
You just map the other clues right around F.
Right, like the clues say box A is immediately below D, 3 boxes are between A and C, G is right above F, and B is right above E.
And if you methodically test those slots around your anchor, they suddenly just lock into a single, undeniable vertical stack.
They really do. So from bottom to top, the reality of this stack is fixed as E, B, A, D, F, G, and C.
Yes. And once you build that structure, the exam just tests your ability to navigate it rapidly.
Right. So for question 66, it asks you to identify the top box, which is obviously C.
Then it tests spatial tracking for question 67, asking how many boxes sit between D and G.
Which would just be the one box, F, sitting right in the middle of them.
Exactly. Then question 68 asks for the immediate neighbor below F.
That's D.
And question 69 asks for the exact position of B from the bottom.
Which is second. I mean, that all feels very straightforward once the stack is built.
It is. But then for question 70, the test does something a little sneaky. It gives you 5 pairs of boxes and asks you to find the odd one out.
Okay.
This is where we shift from fact-finding to pattern recognition heuristics. Because your brain is a pattern-seeking machine, you know?
Oh, totally.
The first 4 pairs it gives you are EB, BA, AD, and FG. If you trace those on our stack, every single pair consists of boxes physically touching each other.
Yeah, the second box is always sitting right on top of the first.
Precisely. And your brain registers that structural rule in milliseconds. But the final pair is DC.
Wait, box C is way up at the top, like 3 places above D, so it breaks the pattern.
It does. And breaking a visual pattern causes this tiny micro-stumble in your cognition, almost like missing a step on a staircase.
Right.
Identifying that stumble is exactly how you find the odd pair out.
Okay, so let's transition that exact same skill from vertical space to horizontal time.
Yes, moving on to the day scheduling.
Right, so questions 71 through 75 ask us to organize 7 people, J through P, who are attending an interview from Monday to Sunday.
It is the exact same cognitive mechanism we just used, just rotated 90 degrees. You're still looking for that anchor.
Right, and the clue says, quote, only 2 persons attend before J.
So that locks J firmly onto Wednesday.
And the dominoes fall again. N is after J, K is after N, and so on. So when the dust settles, the timeline from Monday to Sunday is L, P, J, N, K, O, M.
And once again, the exam fires off those quick retrieval questions.
Right, so question 71, who is on Saturday? That's O. Question 72, who takes Sunday? That's M.
Question 73 asks how many people are between L on Monday and N on Thursday?
That's 2 people, P and J. And question 74 asks, who's the person immediately before Friday's interview?
Which would be N, since K is on Friday. But let's pause here, because the final question in this set, question 75, is really fascinating.
Oh, the meta question.
Yes.
It asks, if these 7 people attend in strict alphabetical order from Monday to Sunday, how many keep their original day?
And this one feels so incredibly taxing on the brain compared to all the others.
It really does. Why is that?
Well, because it forces a working memory overload. You are asking your brain to hold the actual chronological schedule L, P, J, N, K, O, M, while simultaneously generating and overlaying a brand new alphabetical sequence.
Oh, right. You have to overlay J, K, L, M, N, O, P.
Exactly. It is like trying to hold 2 different phone numbers in your head and compare them digit by digit.
That sounds exhausting. And if you force yourself to align them carefully, you see that only one person O, sitting in the Saturday slot, matches up perfectly in both lists.
Exactly. It measures your ability to run 2 competing frameworks without letting them bleed into one another.
Okay, so we've mastered linear lists.
Mm-hmm.
Now for questions 76 to 80, the paper transitions into 2D spatial dynamics.
The square seating arrangement.
Yeah. We're looking at 8 people, A through H, sitting around a square table, and they are all facing the center. 4 are at the corners, and 4 are in the middle of the sides.
Right.
Now, wait, I have to push back here for just a second. Why is it so crucial to track who is at a corner versus who is in the middle of a side? I mean, doesn't a circle work the exact same way as long as the sequence is correct?
So this raises a really important question, and it's actually a trap many people fall into.
Oh, really?
Yeah. While a circle is continuous and uniform, a square creates an alternating geometry.
Okay.
Corners and middles have fundamentally different relational properties. The person opposite a corner is always another corner.
Oh, I see.
And the person opposite a middle is always another middle. So when the prompt says H sits at a corner, it anchors the entire geometry.
Right. It locks an alternating pattern of corner middle into place for everyone else.
Exactly. It acts almost like a compass rose.
Got it. So following the directional clues, like B is second to the left of H and C is between them, we can map the clockwise order starting from H at a corner.
And that order goes H, then C, B, F, D, A, G, and finally E.
And once that mental map is drawn, the paper just demands you navigate it. So question 76 asks, who sits second to the right of A?
But because everyone is facing the center of the table, right and left feel inverted depending on where they sit, don't they?
Yeah, they really do. It's super confusing.
This is a test of spatial perspective taking. You literally have to put your mind inside A's position.
Okay, so if A is at a corner, facing the center, moving to A's right means moving counterclockwise around our map.
Tracing that path, the immediate right is D, and second to the right is F.
Got it. Then question 77 asks, who sits diagonally opposite C?
Since C is in the middle of a side, diagonally opposite just means straight across the table.
Which, following our layout, is A. Next, question 78. If we count clockwise from E to B, we pass exactly 2 people, right? H and C.
Correct. Then question 79 asks us to group the 4 corners.
Which is just every alternating person starting from H. So H, B, D, and G.
And just like the box puzzle, it ends with a pattern breaker for question 80.
Oh, right.
It gives you 5 pairs of neighbors, like BF and DA, and in 4 of those pairs, the second person sits immediately to the left of the first person.
But the pair ED breaks the rule, right? Because E's immediate left neighbor is H, not D.
Exactly. It's amazing how quickly you can spot the anomaly once the structure is actually built.
It really is. But now we are leaving the physical world behind entirely. We are entering what I like to call the logic gym.
Pure abstract deductive reasoning.
Yes. Questions 81 through 87 cover syllogisms and coded inequalities.
Syllogisms are brilliant, really, because they force you to detach completely from reality.
Yeah.
You have to rely solely on the relationships provided by the premises, just completely ignoring your real-world knowledge.
Which brings us back to that beautifully absurd statement from our intro for question 81. Statement 1, all roses are flowers. Statement 2, no flower is a leaf.
Okay, so let's unpack this.
The conclusions we have to test are 1, no rose is a leaf, and 2, some leaves are roses.
So the only reliable way to process this is visually, using Venn diagrams.
Okay, I'm visualizing it.
Draw a small circle for roses entirely inside a larger circle for flowers.
Got it.
Then, draw a separate circle for leaves that is explicitly forbidden from touching the flower circle.
Right, because no flower is a leaf.
Exactly. Because roses are trapped inside flowers, they can never touch leaves. Therefore, conclusion 1, no rose is a leaf, is absolutely true.
And conclusion 2 is just structurally impossible, so only I follows.
Right. Let's try another one for question 82. All pencils are pens, some pens are erasers.
Okay, and the conclusions are 1, some pencils are erasers. 2, some erasers are pens. See, my brain automatically wants to draw a line connecting pencils directly to erasers. Why is it so hard to just accept that we don't know?
Because the human brain really craves cognitive closure, we just hate ambiguity.
Oh, yeah.
When we hear pencils are pens and pens are erasers, we desperately want to close the loop and say pencils are erasers, but look at the Venn diagram.
Okay.
The pencil circle is inside pens. The eraser circle overlaps with pens, but does it reach far enough to overlap with pencils?
I mean, it might, but it might not.
Exactly. We cannot declare it a certainty, so conclusion 1 fails. However, if some pens overlap with erasers, then inherently some erasers overlap with pens.
That is a direct logical conversion. So only conclusion 2 follows.
Exactly. Let's escalate a bit for question 83. Some chairs are tables, some tables are desks.
And the conclusions are 1, some chairs are desks. 2, no chair is a desk.
Now, what's fascinating here is a concept called the complementary pair. Standing alone, neither conclusion is definitively true because chairs and desks might overlap or they might not.
Right, but a chair either is a desk or it isn't a desk. There's literally no third option in the universe.
Exactly. Think of it like a light switch inside a closed, windowless box. You don't know if the light is on, you don't know if the light is off.
Okay.
But you know with 100% certainty that it cannot be both and it cannot be neither. Those 2 options cover the entire reality of the box.
Oh, that makes so much sense.
Because these 2 conclusions use the same subjects and cover all possible states of existence, one of them absolutely must be true. So the correct answer is either I or 2 follows.
That is such a satisfying way to frame it. The final syllogism, question 84, is pretty straightforward. All keys are locks. No lock is a door.
So can some keys be doors?
No, they are trapped in the lock circle. Are all doors keys? No. There is no connection. Neither follows.
But from here, the abstract logic takes a slightly different shape with coded inequalities.
Right, questions 85 to 87. This is where they take simple mathematical concepts like greater than, less than, equal to, and hide them behind symbols like the @ sign, hashtag, or $sign.
Yeah.
I have to say, this whole section feels like it isn't testing math at all.
Yeah.
It feels like it's just trying to exhaust my working memory by making me translate a secret code before I can even look at the actual problem.
You've hit the nail right on the head. It is entirely a test of cognitive load.
Really?
Yes. And the trick here is to just refuse to play their game. Do not try to solve it while it's still in code. Translate the entire string into standard mathematical inequalities first.
Okay, let's do it for question 85.
Yeah.
Once translated, the first string becomes A is greater than B is greater than or equal to C, and C is equal to D.
Strung together, that's A, B, O, C equal D.
Right. And the test asks if A is greater than D.
Following the flow, yes, A is greater than the rest of the chain.
Then it asks if B is greater than or equal to D. Since B is greater than or equal to C, and C is literally identical to D, yes, both follow.
Perfect. Now, question 86 translates to M is less than N is less than or equal to O, and O is greater than P.
So the chain is MNAOP.
It asks if M is less than O. Yes, the signs all point the same way, but then it asks if N is greater than P.
Oh, and here we hit the logical wall?
Exactly. Look at the chain between N and P. N connects to O and O connects to P, but the signs point in opposite directions.
Right. N is less than or equal to O, but O is greater than P.
When the signs reverse like that, it's like a bridge collapsing. You simply cannot compare N and P based on this information. You have absolutely no idea which one is bigger.
So only the first conclusion follows.
Exactly. And the final inequality, question 87, works the exact same way. The chain is X, U, Y, Z, A, W.
It asks if X is greater than W. Again, we hit the reverse signs at Z. The bridge collapses. We know nothing about X relative to W.
Right. Then it asks if Z is less than X. Looking backwards, X is greater than or equal to Y, which is strictly greater than Z.
Therefore, X is strictly greater than Z, meaning Z is definitely less than X. Only the second conclusion follows.
Fantastic. We've successfully survived the logic gym.
Phew. Now, for questions 88 through 93, the paper brings these abstract symbols back down to earth with highly relatable human scenarios, family trees, and walking directions.
Yes, blood relation problems. These require methodical mapping, very much like our earlier seating arrangement, but you are mapping generational hierarchies instead of physical space.
I always laugh about how convoluted these sound compared to normal family gossip. Like question 88 says, M is the father of N is the sister of O is the son of P. How is P related to M?
So just map the tree. M is the father of N and O, who are siblings.
Right.
The prompt then says O is the son of P. Well, if M is their father and P is their parent, P must be their mother.
Therefore, P is the wife of M easy.
Then we get a classic riddle for question 89. Pointing to a man, Sita said, "He is the son of my mother's only daughter."
Okay, so break down the noun phrases. If Sita is speaking, my mother's only daughter, it's really just a complicated way of Sita referring to herself.
Exactly. So the sentence simplifies to, he is the son of myself.
He is her own son. But question 90 is definitely a trap. Q is the brother of RS, is the mother of Q. T is the father of S. How is R related to T?
Let's trace it. S is the mother of Q and RT is her father, so T is the grandfather.
The question asks how R is related to T. So R is the grandchild. But wait, we know Q is a brother, so Q is male. We actually don't know if R is a boy or a girl.
And this is a really vital point. The human tendency is to fill in the gaps and make assumptions based on names or feelings.
Yeah, I almost just assumed grandson.
Right, but in strict logic, you never assume information that isn't explicitly stated. Because R's gender is unknown, R could be either a grandson or granddaughter.
Got it. Okay, we transition from family trees to physical space with direction sense in question 91. A man walks 5 kilometers north, turns right, and walks 3 kilometers, turns right again, and walks 5 kilometers. Where is he relative to the start?
So he goes north 5, east 3, south 5. The north and south movements perfectly cancel each other out,
leaving him exactly 3 kilometers east of his starting point.
Question 92 asks for the shortest distance between a 0.6 kilometers south and another 0.8 kilometers east.
Right.
Whenever you see the phrase shortest distance combined with right angles, your brain should immediately deploy the Pythagorean theorem heuristic.
Of course. You've basically drawn a right triangle with legs of 6 and 8.
Exactly. Square them, add them up. 36 plus 64 is 100. The square root of 100 is 10. The shortest distance is a perfect 10-kilometer hypotenuse.
Question 93, the last spatial question, introduces rotation. Rahul is facing west. He turns 75 degrees clockwise, then 90 degrees clockwise, and finally 135 degrees anti-clockwise. Which direction is he facing now? I always try to visualize spinning around in an office chair for these.
And that is exactly what they want you to do. But mental rotation requires a massive amount of cognitive processing power. It's completely exhausting.
So what's the trick?
Bypass the visualization entirely and just use simple math.
Oh.
Assign clockwise as positive and anti-clockwise as negative. Plus 45 plus positive 90 is positive 135.
Then he turns negative 135. So the net rotation is exactly 0. His orientation hasn't changed at all. He is still facing west. Okay, we are on the home stretch. The final sprint covers questions 94 through 100, pattern recognition, order ranking, and coding. And by this point in an exam, fatigue is setting in really hard.
It is. These final questions are the true hallmark of a sharp mind. Can you maintain focus and accurately process seemingly chaotic data when your brain just desperately wants to rest?
If you are listening to this right now, think about how you scan a crowded room for a friend. You don't look at every single face sequentially, you know. You filter for a red jacket or a specific hat.
Exactly.
That is exactly what you have to do with this next puzzle. Questions 94 to 96 give us this chaotic string of letters, numbers, and symbols. Question 94 asks, how many symbols are immediately preceded by a number?
Tell your brain to turn all the letters invisible. Just scan for the symbols.
Okay, scanning. We find a percent sign, a hash, dollar, star, and ampersand.
Now look directly to the left of each. Percent follows a 4, hash follows a K, dollar follows a Y, star follows a 9, and ampersand follows a 2.
So the percent, star, and ampersand are preceded by numbers. That's 3 symbols.
Right. Next, question 95 asks to find the element 6th to the right of the 4th element from the left end.
So left end, moving right.
Don't count twice, just add them. 4 plus 6 is 10. You need the 10th element from the left.
Which is the dollar sign.
Exactly. Finally, question 96. If all symbols are dropped, which element is 11th from the right end?
If you drop the symbols, you're left with 15 letters and numbers. Counting 11 from the right is basically the same as counting 5 from the left. So the answer is K.
Excellent. We then hit order and ranking for question 97. In a row of 40 students, Ram is 15th from the left, Shyam is 20th from the right. How many sit between them?
Okay, so to compare them, we have to orient them to the same side, right?
Yes. If Shyam is 20th from the right out of 40, his rank from the left is 40 minus 20 plus 1.
So he's 21st from the left. Ram is 15th, Shyam is 21st. The students between them are at positions 16, 17, 18, 19, and 20.
Which is 5 students.
Now let's pause on the math for question 98. Meena ranks 12th from the top and 19th from the bottom in her class. How many students are there? Honestly, my brain instantly just wants to add 12 and 19 and say 31. Why is that wrong?
Because of the off by 1 error. It is a very common mental glitch.
The off by 1 error.
Yeah, human brains are wired to count discrete items, not overlapping boundaries. If you add 12 and 19, you have actually counted Meena twice. Once from the top group and once from the bottom group.
Oh, so you must subtract 1 to correct the overlap. 12 plus 19 is 31, minus 1 is 30, the class size is 30.
Exactly.
2 questions left. Question 99 is coding and decoding. The word garden is written as ICTFGP. How is flower written?
Look at the underlying mechanism. Compare the first letters, G to I.
In the alphabet, it just skips H. That is a shift of +2. A to C is also +2, so the whole word just shifts by 2 letters.
Right, so apply that structural rule to flower.
F becomes H, L becomes N, O becomes Q, W becomes Y, E becomes G, R becomes T. So H and Q, Y, G, T.
Perfect. And the final question, number 100. How many pairs of letters in the word spring have as many letters between them in the word as in the English alphabet?
Okay, so you just have to mentally check the gaps.
Right. And the only one that fits is I and G.
Let's see. In the alphabet, it goes G, H, I. There is 1 letter between them.
And in the word spring, there is also exactly 1 letter N between I and G.
That is 1 pair matching the standard spacing. And with that, that concludes all 35 puzzles of the reasoning section. We did it.
We really did.
If you made it through this entire sequential gauntlet with us, congratulations. We didn't just find the right answers. We mapped out the mental framework required to categorize, visualize, and deduct calmly under pressure.
And you know, that is the real takeaway here. These tests measure how well you can suspend assumptions, manage your working memory, and strictly follow structural rules.
Yeah.
Which actually brings up a rather profound reflection on how our minds operate outside of the exam room.
Oh, how so?
Well, we just spent 20 minutes ruthlessly checking the logic of artificial puzzles. We required absolute, unshakable proof before deciding if a rose could be a leaf or if an uncle could be a grandfather.
Right. You were super strict.
But think about how often in our daily lives we make wild, unsubstantiated assumptions about people, situations, or, headlines we see online.
Oh.
Assumptions that would spectacularly fail a basic syllogism test.
It's so true. We demand perfect, airtight logic from a piece of paper, but we accept incredibly sloppy logic from ourselves every single day.
Precisely. We let the off-by-one errors and the reversed logical signs slip right past us when we're emotional or rushing.
Yeah.
So the next time you find yourself jumping to a rapid conclusion in your real life, ask yourself, are you drawing a solid logical line based on the explicit facts in front of you, or are you just guessing in the dark?
That is definitely something for all of us to mull over. Thank you for joining us on this deep dive. Keep training that brain, keep questioning those assumptions, and we will catch you next time.